Now let us study an important phenomena which is called total internal reflection. About this we can write, this phenomena can take place only when a light ray travels from a denser medium to rarer medium. To understand the phenomena, let's have a look on a physical situation. Here you can see there is a glass-air interface on which a light ray is incident from the side of glass, which is a denser medium, and it incident at an angle I to the normal to the interface, and from this point a part of light is always reflected and a part is transmitted to the other medium, which is the refracted light. And here you can see the reflected light is also at the same angle I, which is following the law of reflection, and the transmitted light is following the law of refraction. It is refracted at an angle R, and here the angle I and R can be related as mu of glass multiplied by sine I is equals to mu of air multiplied by sine R. In this situation, as the boundary is transparent, the reflected light will be very faint and the intensity of light is low. Maximum light is transmitted to the other media. Now here if we increase the angle of incidence, here you can see as I increases, the value of R also increases. And when the value of incidence angle approaches to a particular value, the value of R becomes 90 degree. In such situations, the refracted ray is grazing along the interface or the boundary of air and glass media. This is called grazing ray. And here we can state this angle to be critical angle. So we can write for I is equals to theta c, which we term as critical angle. The value of R becomes 90 degree. So in the situation, from this relation we can write mu g sine theta c is equals to mu of air, which in this situation we can consider as 1, or if there is another media we need to take the value, and sine 90 we can take as unity. So here the value of critical angle is coming out sine inverse of mu a by mu g. This is the angle which we define as critical angle for air glass interface. Now if the angle of incidence is increased beyond critical angle, here we can see no refracted ray can be in existence, and as soon as the value of I is slightly increased, overall intensity of light is reflected in form of reflected ray only, and no refracted ray will exist after I more than theta c. Here you can see if I is less than theta c, both rays will exist and reflected ray is quite faint. But beyond theta c, only reflected ray will exist and no refraction will take place. And this is the state we call total internal reflection. So we can write for incidence angle more than critical angle, light is internally reflected at the boundary of two media. Even though the boundary is transparent, both the media are transparent, even after that the light is completely reflected if the incidence angle is more than critical angle. If incidence angle is equal to critical angle, here we can consider that a refracted ray is just grazing along the boundary and reflected ray still exists and it follows the laws of reflection.